Let's talk about creating our own custom binary files. Alright, so why would you want a binary file? And I guess if you don't know what is a binary file? Well, a binary file is simply put just a file that's stored in binary. It's created of just ones and zeros. We don't have something like a text file or a JSON file where it's text based and we could open it up, we can read it, we can take a look at it, edit it, save it. It's not like that. A binary file is all ones and zeros. We're not going to be able to just open it up and take a look at it and make some edits. Maybe if you have a specialized tool, maybe you can go ahead and make some small changes, but for the most part, you're not going to be opening it, you're not going to be reading it, you're not going to be editing it, and it's going to take up much less space at the end of the day. So something like save files. I know there are some games where some people play on the same save for years, and eventually their save files start getting pretty big. And maybe if you're on, say, a mobile device, or you're going to offer cloud storage for your game or games, you're going to want to, of course, take up the least amount of space as possible, not only for yourself to save yourself on money or space, but to just not be rude to your end user. So let's go ahead and take a look at it. We're going to start with, I'm going to show you how to create a binary file to start with, and then we're going to make iterations and progress so we can move towards a custom file and take up even less space. So I just have a scene here for us to take a look at. No big deal, it's just a control. I'm going to throw a script on there. Now, if you're doing this in a game, of course, you're probably going to have a save manager set up for yourself, but I'm going to go ahead. Sure, main, doesn't matter, that's fine. And what I'm going to use is we're going to have a save path. And for this, I'm just going to go ahead and I want to use user. Yeah, we'll use user. Why not? And as an example, I'm going to have my demo save data here. Now, for this, it's just a simple dictionary called save data, right? We have some player information, right? The name, level, position, their inventory, stats, and then we have some flags that might be used here. It's like tutorial completed is true, whether they have defeated the boss of the game, true or false, right? So we just have some simple data there, right? Our save path, and an example of maybe a dictionary that you want to save to be used later. So what we're going to do is we're going to go ahead and create a save game function. Right? We'll go ahead and put that in. Now, this is going to be really simple and not take a whole lot of effort. So if you've never made a binary file before, don't worry, it's not too complicated. Okay, so what we're going to do is, just like any other time, we need to open up our file. So var file, if you want to type it, file access, right? And that's going to be our file access.open, our save path, and we're going to be saving in it, so we're going to be using write for our permissions, right? So far so good, nothing crazy, everything pretty familiar. And like always, we're going to go ahead and check, make sure it's not null, right? We want to make sure everything's okay. So we can say, we can do a null check, or we can say if not equals okay. Right, whatever way you want to go about it, I'm going to use okay. If it's not okay, then we can go ahead and print out a message for us. You know what? That's my mistake. Whoops. That's my mistake there. The open doesn't return an error code; it just returns a file access. All right, so null check it. So if there's an issue, then we can just print out, hey, there's an error opening the file, and use file access get open error so we can see what the error is. And then I'm just going to return false. All right. So far we've tried to open it. If we can't open it, there's an issue. The user knows. And now we need to actually store our information. Now, in order to store this in binary format, what we're going to actually use is a function called store, and you can see we've got 18, 16, 32, 64, buffers, CSV line, doubles, floats, half, line, Pascal strings, real string, var, and so on, right? So we're just going to use store var. In this, we can just go ahead and pass in our dictionary. So it's going to be our save data. And that on its own is going to turn this into a binary file for us. So if you want to be extra safe, you can just go in, file close, but we shouldn't have to. It should automatically close for us, and then we return true. Right, so we're going to return back a Boolean of some sort. And now what about that load game? All right, so let's go in, we'll do a load game. There we go. We're going to start off in a very, we're going to be starting off in a similar form, but of course it's a load, so we want to make sure the file exists. So file access dot file exists, pass in the save path. All right, so we're going to go ahead and do that check, and if it doesn't, then we can go ahead and print no file exists. Simple as that. If it doesn't exist, then we don't have to save, or sorry, there's nothing for us to load. I'm just going to return null here. If I can spell, return, not returner. Alright, so now that we've made sure that it works, or that the file exists, we're going to do it just like we did up top. Inside of our save, we'll get our variable file. We'll open up the save path. In this case, we need to read permission, not write. All right, so file access.read. If file is null, error opening, get the error code just like we did before. And now to actually get this data, we can go ahead and we can say, or we can get our save data. So say var data equals file.get var. Now, if you have this in, if you're storing multiple variables in here, when you get var, you're going to get this in the same order that you saved it in. So keep that in mind if you're storing multiple things here. And we're just going to go ahead and file close. And we can return data. All right. So for our example use case here up in the ready, all we have to do is come in there and we can just do save game. See if we run it. All right, I'll open up the user directory. And there's our save data.bin. And if I try to open it, it's gonna be like, hey, what do you want to open this with? So let's take a look at Notepad. If we try, this is what we get. All right, so it's an unreadable format for us. And that's fine, that's a binary file. Now it doesn't matter if you're using .bin, .sav, whatever you want to use, right? It doesn't really matter at this point. .bin is just a common extension, just simply means binary. Right, and what about loading it? Well, if you want to load this up for an example, all we have to do since we are just dealing with save data and nothing else here, we could just come in and say save data equals load game. Oh, I'm sorry, I said save game. I typed there, not save data. There we go. Save data equals load game. But if you have multiple things in here, set up again, multiple variables going, then of course you can come in and create your own temporary data. Say var data equals load game, and then you can come in, of course, and if data, and then start assigning things, right? So we can say whatever this is, right? Save data, player name, right? We can come in, save data, player name equals data, player name, right? We can come in there, we can assign things one by one. But since I only have one dictionary that I'm storing, that we're using for this example, we're not storing multiple variables in here, I can just say load game equals data and just call it a day. Right, and we can go ahead and we can take a look at this. All right, just so you can see that it's working. So I'll say print, save data. Right, and we'll do player name. Right, so we'll see initially that's going to be hero. It's not much of a comparison if I don't do it there. And there we go. You see, we take a look and we see it's hero both times. Great. Now I'm going to stop the save. Actually, we're going to need another save here in a moment. But I'm going to come in here. I'm going to change the name to say, hey, Jimmy. I'm going to save the game. All right. Now, if we stop saving and we go ahead and load, I'll change this back to hero. We'll see that the first save should give us hero, and after we load it, we should get Jimmy, and that'll show us that everything's working. Our hero. I forgot to change that back from just data to being our save data directly. That's my fault, but if we take a look, you can see hero, which is our original name, and Jimmy when it loads. So we can see there, the file is loading up. Everything's just fine. We have no errors. We're getting any changes in comparison to the original file. So there you go. We can see binary works. It's perfectly fine, and it's smaller than a text file, for sure. Now, what if we want to take it up a level? What if we want to make some changes? We want to start creating our own files. All right, so now, what if we want to make it? What if we want to go ahead and start creating our files? Well, to do that, to start creating our custom files, we're going to need something called a header, and this header is what defines the file type. Essentially, a PNG will have its own header, and any program that opens a PNG knows what these headers are, and it looks for it in order to load the data. A JPEG is going to have its own data, its own header. It's going to be completely separate from a PNG. PSD is going to have its own header, and of course, this doesn't just extend to these image file formats, but it goes into any file that can be stored on the computer. You would imagine any extension, it's going to be its own dedicated format. So whatever extension you can think of, it's got its own header type. And that's what we're going to do here. So in order to do this, we're going to go ahead and I'm going to show you the most readable way for yourself here. We can go ahead and create a constant. This is going to be our file header. And we can store this as, for this example, any string that you want, right? So I'm just going to use gsave. And because we're now going into custom file headers, I'll go ahead and now even put this data as gsave, right? Just for my own extension. Now, as well, we're going to go ahead and keep track of a file version. So we'll say file version. We're going to say this equals file version 1. Now you could always split this up. You could have a file major version, file minor version, if you wanted. Now we can come down to our save game and we can look at what do we actually need to change here. Well, what we're going to change is actually going to be very minimal. All we're going to be looking for is right down here where we're storing this data. And we need to just make a small change. We're going to keep store var, but above that, we're going to have a file dot store string for this, we could say. And we'll just pass in the file header. Again, this isn't my preferred way of doing this, but that's what we can do. And we can do file store. We have 8, 16, 32, and 64 here. I'm going to use 32. This is just going to give me a wide range. I could even use 64, but if you want to minimize space, you can always go with store 8 for the file version. And if I'm being honest, store 8, if I'm not mistaken, will go all the way up to 255. So if you have more than 255 major versions of your game, I don't know, that is insane. Your game's been going on for an extremely long time. So in reality, store 8 is more than enough for the majority of people. I'm just going to go with store 32 just for the extra headroom. Not that it's going to matter in this example. And I'll store the file version. And if you're doing a major, you can do it there. If you're doing a minor, you can store that next. And then we have our store var, file close, and so on. Now, if we come down to our load game, we're going to have this info is all right. We need to get we need to check the header. I was going to say the hider. We need to check the header to make sure that we have the right file that we're trying to read. And to do that, we're going to do that right after we got access to the file. We want to make sure the file isn't null. So right after we do the null check, we'll go ahead and check the information. So we'll say var, whoops, I have caps on, var header equals file dot get buffer. It's going to be file header dot length, right? So we're going to get the length of our header and we're going to get that out of the file. And now we can go ahead and check, and we can say var header string is going to be header dot get string from UTF-8. And now we can actually check if header string is not equal to our file header. Then we can go ahead and we can just say invalid file header. We expected this and got this. And close the file, return null. Right? Exit out of it. Wrong header. We can't read this file. It's not supported by our game. Now, if you want to do version checking now, our next step is going to be file version equals file dot get 32. And now, as you see, in my case, I'm just going to print it out. For this, we can say loading save version, show us what version we're loading. And if you want to go further and do some comparisons, you can do if version is greater than the file version, right, of our current game. We can go ahead and print out, hey, this is from a newer version. And likewise, you could say if the version is lower than the file version, then, right, maybe you prompt the user to upgrade their save. That way you can make sure that their old save is now compatible, or convert it so that it is compatible with the new save in case you have new data in there. You can do all that stuff in here, or at this point, right, with these version checks. But after that, all that's left, we've already got the header and we've got the version. All that's left is just to get that var out of there, which is our data 32. That was weird. Why did I say data 32? But that is our data. Close the file, return the data. Right? All that is the same. So with our version in there, the header string in there, we've gotten the header out. If we run this, I've went ahead and I changed it to gsave, but I did just run the save just as we did before with Hero and Jimmy. So if I run this now with our load, we should get the exact same results. Right? We should still get Hero and then Jimmy. There we go. Hero, loading save file version 1, and Jimmy. All right. Perfect. So we now have a binary file. We now have our own custom header, so we can create our own file types. What's next? What's the next step that we can do? Well, we can take it a step further and we can begin compressing this file. And I'm going to tell you there's a very simple way to do this compression at a basic level. And all we have to do is look at store var down here. All we have to do is look at store var, save data, the second argument, we'll just pass it in as true. And we can come on down and same thing with data, get var, pass in true. All right, so with just adding true, in there for store var and get var, we're doing nothing else. I'll come in here, I'll change this name to Jimmy. We're going to be saving it in the ready. I'll run it. And for comparisons, I did change it to gsave2 for this. Change that back to Hero. Remove save, uncomment our load game, and just see everything still works just fine. Hero, loading save, and Jimmy. Alright, so how can we step it up from here? Well, by one last thing, we're not going to use a string for the file header. Instead, we can use bytes directly. So instead of passing in a string of gsave here, we can use a packed byte array. And Donna wants to yell at us for making it a constant. Fine, whatever, we'll change it to a variable. A packed byte array. If you know your ASCII hex codes, this is the same thing. It just spells out gsave. So this is the letter G, S, A, and V. You can find these tables online. If I remember, I'll link one in the description. All right, and then file version, all of that is the same. All we have to do now is we'll come down to our save here, and instead of where's our buffer? Right here. Instead of store string, we're going to use store buffer, which takes a packed byte array. So now we can pass in that file header. So we're using store buffer instead of store string. And we can come down to the load game. And we are looking for our header right here. So instead of getting for the header, sorry, we don't need a header string anymore, right? Because we're not working with strings, so we can get header is then going to become file.getBuffer or file header dot size, right? Instead of length. And now with our check here, header string is not compared, so we can go ahead and change header string to just being header. So if header does not equal file header, Then our print statement is going to have a minor change because we're not working with strings anymore. So invalid file header expected, and we can say file header dot hex underscore encode. We got header string, which of course isn't what we want. We want header dot hex encode. Right? And close the file, return null if the header doesn't check out. And version and data and all that is still exactly as it was previously. Right? We can still use true for compression and decompression. Although depending on what it is you're storing, you may or may not see much of a difference. But that's it. Go ahead, run it. Oh, and we're running into an issue there because we have a completely different header now. So let me just go redo my save. Alright, so I'm now using gsave3. And we went and did our Jimmy save. We'll load it up. And we got a hero, loading save, and Jimmy. So everything still works. So the packed byte array is the more preferred and standard way of doing your headers rather than using a string. But if you really wanted to use a string, you could. And I have all the files up here. So we have our regular binary file, which is at 396. And then gsave, we added our string header and file version. So it brought us up to 405. Then we added compression, which kept us at 405, which just tells us that the data we're storing isn't actually going to benefit at all from this compression. But depending on what you're storing in the future, you might see a great benefit. Personally, in files that I've done in the past, I have brought things from like 200 megabytes all the way down to 12 megabytes. So depending on what your data is, compression could give you a huge save in space. And the last one went from 405 to 404, so we saved 1 byte. If I can remember how, there we go. So we saved 1 byte just by changing this from a string to a byte array. So just by using these codes instead of a string, we've already saved space. Alright, and we got one more thing to show you here, and we're going to be doing this is going to be showing our own compression, and we'll be able to choose from different compression types. Alright, this video is already getting pretty long, so to save on time, I went ahead and I've already written it out. We already know what we're doing here, so we're going to take it up to another level, and we're going to have our own custom compression going on. So we go ahead, we create a new constant for compression type, file access.compression underscore 0z_std, and you could use any of the options here. If I just do an underscore, you can see them all here. And if you were to take a look at these inside the docs, you'll have a link out so you can read more about these. Alright, so I'm going to use this for now. We can take a look, and just for reference, I've already done my save, so I can just run my load later. Alright, so in our save, what we're going to do that's different here is we're going to do var data bytes. We're going to use var to bytes. This automatically happens when you use store var. So we're doing this stuff manually now. So var to bytes, passing our save data. Our compressed data, because we want to compress, is going to be databytes.compress, and then pass in the compression type we want to use. Then we're going to store 32 databytes.size. We need to use this later. I did not mean to click on that. We're going to use that later when it comes to reading. We're going to store 32 the compressed data.size. Again, we'll use that later. And now file.store buffer. So we're using store buffer instead of store var now. So store buffer, our compressed data, close and true. Now to load the game, after we've gone ahead and checked for our headers, to get our actual data, we create variables for our uncompressed size, which will be our first file get32. Then uncompressed size is our next get32. Remember, this is in the same order that we saved it in. Now the compressed data is we're going to use get buffer, pass in our compressed size. And now to decompress the data, we're going to create a variable for that, decompress data. That'll be our compressed data dot decompress. Pass in the uncompressed size and our compression type. So now we can go ahead and check. If decompressed data.size equals 0, then we've failed to decompress it. So error, failed to decompress saved data, close the file, return null. Otherwise, our data can be set to bytes to var, decompressed data, so we can turn it back into something that we can read. And that's it. Everything else remains the same. Save data equals load data. We can take a look. Fantastic. All right, now I'm going to go ahead and make a few more saves with different compression types. So I'm going to say 5, and I'm not going to go ahead and bother with the loading. I'm just going to show you different types here. So you see, we just change the compression type here, run it, and we're good. And I'll go ahead and show you this one time with the load. You can run that. You see, we have no problem decompressing and taking a look. So all you have to do is just change this one variable if you want to try different types. So come in 6. So we've done 2 of them. Say it broadly. Run that. Right. So we've done a few of them now. And if we go ahead and take a look, we can see we have what? 4 is 257 bytes. So just by doing this compression ourselves, we've already cut this, not totally in half, but 404 down to 257. That's a huge reduction. Game Save 5, where we used the gzip, went down to 244, so that was a little better. And Save 6 took us all the way down to 16 bytes. So there you go, you got some numbers. Now personally, I'm using the Z or Z STD or gzip when I do compressions. So it's up to you which one of those that you're going to use. I'm going to use a gzip. If size is a huge factor, if I want to squeeze out, or if I want to save every last byte that I can, then I'm definitely using gzip. If you want to be standard, use the ZZ STD. And again, you could use your magic numbers here instead of a string. But alright, I know this was quite a long video now. But there you go. There's how you can there's how you can save your data as binary files. And every step along the way, so you can go from normal binary files to creating your own file types, to doing your own magic numbers, and doing your own compressions. Alright, there was a lot in this video. Hopefully you learned something from it, and that this all wasn't a waste of time. But alright, take care, have yourselves a good one. Again, if I remember, I'll put that little cheat sheet or a link to the cheat sheet down in the description. And I'll see you guys next time.